Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So today we'll be looking at organic chemistry, and we're going to be introducing organic chemistry. And we'll start by saying that organic chemistry is the branch of chemistry that deals with the structure, properties, reactions of carbon-containing compounds, especially hydrocarbons and their derivatives. Okay, so it's a study, it's a branch of chemistry that deals with structures, properties, what else? And reactions of carbon-containing compounds. Yes. Not just, okay, especially hydrocarbons. Hydrocarbons. So hydrocarbons is just carbon and hydrogen together, and their derivatives. Okay, so we are going to be studying these kinds of, and it's very interesting. So carbon atoms have unique ability to form long chain, daisy long chain. Concatenations and form covalent bonds. So when you hear carbon, organic chemistry, hydrocarbons, you covalent bonds come to your mind. Okay. So it forms, this carbon forms it with hydrogen or oxygen. So you can have oxygen attached here, hydrogen attached here. Anyhow you attach it, you see that there's a covalent bond formed, and other carbon atoms. So hydrocarbons actually, again, are organic compounds composed only of carbon, C, and hydrogen, H. So you see them, that's why we call it hydrocarbons. They are classified into broad types. Broad types classified into the alkanes, ANE suffix. You have the alkanes, ENE suffix, and you have the alkynes, YNE suffix. So this if you have difficulty in pronunciation, just make sure that the suffixes, what is attached to the alk, ALK, the suffix for alkane is ANE, ALK again, suffix for alkynes is ENE, and ALK again, suffix for alkynes is YNE. So these are the broad classifications of hydrocarbons. So we'll dive into these classifications and have a sneak peek review. Okay, so we'll go into the classes of hydrocarbons, like I said. So I have a table here that just have a broad description. So I have the three classes here: the alkanes, the alkanes, and the alkyne. Alkane, alkanes, and alkyne. Okay, so there's a general formula for each of them to derive them. The names are derived from the number of carbon atoms that are in each of them. So if I have one carbon atom, the only one that falls into the category that have one carbon atom is the alkanes, and methane is the first one. Okay. If you have two carbon atoms in any of them, it takes the name ethane. So you have ethane, H is 2, ethane, ANE for alkanes, ethyne, ENE for ethyne, then ethyne, YNE for ethyne. So you see that for H, there are two carbon atoms. For prop, 3 carbon atoms. For boots, you have 4 carbon atoms. For pent, you have 5 carbon atoms. For hex, you have 6 carbon atoms. And for hept, you have 7 carbon atoms. For 8, you have oct, you have 8 carbon atoms. For noon, I didn't put noon and dec. So noon is 9, nuna, and 10 is decane, nunane and decane. But I didn't put that one. So there's a general formula for it. If you put where n represents the number of carbon atoms. So for 18, carbon atom 1, or you put 1 here, that you have carbon 1 here, you put 2 times 1 is 2, 2 plus 2 is 4, that's why you have 4. So if you have 2 carbon atoms for this situation, this formula goes, you put 2 here, that is 2 carbon atoms, you put 2 here, 2 times 2 is 4, 4 plus 2 is 6, that's why you have 6 for the 2 carbon atom hydrocarbon, that's the 8. For the 3 carbon hydrocarbon, 3 carbon, when you put N as 3, and so on, understand? So just be putting N for the number that you are looking at, you will get the chemical formula for that particular hydrocarbon. So general properties for all the alkanes, this is the general formula for the alkanes. General formula for the alkanes, number 1. Then they form single bonds between hydrogen carbon. So each of them, I can draw the structural formula for all this. For methane, I can just come here, just put a C here, and every other part of the C has hydrogen with it. For the one that has 2, I can do something like this, C, C, and so on. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. So this is the structural formula for all of them. So there are single covalent bonds for the alkanes. Okay, so like example, you have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. All of them are following the number of number naming system for each of the number the number of carbon present in them. Okay, for the alkanes, ENE surface, they are unsaturated hydrocarbons. We said this one are saturated. Why are they saturated? Because every space is completed, the possible spaces. So if I have methane, for instance, 1C, every space, there are 4 attachments, supposed to be 4 attachments, so none of them is free. That's why it's saturated. But for alkanes and alkynes, they are both unsaturated. So this is unsaturated. Let me just put here saturated. This is if you can't know anything about it, just know that this one is saturated. Every space is filled. This one is unsaturated, and this one too is also unsaturated. Okay, both are unsaturated. Why? Because there's always a free space. So this general formula for alkanes. Examples include ethyne. It didn't start with methane. So you have ethyne, propane, butane, pentane, hexane, and so on. Okay, so for alkynes, also starts with ethyne, propine, pentane, hexane, heptane, and octane until it gets to decane. Okay, so this is general formula, and they are also unsaturated. So physical properties of hydrocarbons include that, number 1, they are non-polar and insoluble in water. That's one physical property of water. Another physical property of water is that, of hydrocarbon, let's say water, hydrocarbon, is that they have low boiling and melting point. So they both have low boiling and melting point. Then they are also flammable, very readily gets burnt, very readily flammable. Okay. So we can't talk about organic chemistry without looking at this concept, isomerism. What is isomerism? So isomerism occurs when 2 or more compounds have the same molecular formula but different structural or spatial arrangements. Okay, so there are 2 types. The first one is structural isomerism. So if in structural isomerism, how do you spell out this word? Structural isomerism. Okay, so this is one type, structural isomerism. So this one has same molecular formula, and different structural formula, different structural formula. Okay, so example of this kind of isomerism is butane. Butane exhibits two kinds of structure. I have it like this: CH, CH3, CH2, CH2, CH3. This is butane. Also, you can have it as 2-methyl propane. 2-methyl propane. So you have it as CH3, CH, then CH3, and CH3. If you look at it now, the both of them contain the same 1, 2, 3, 4. 1, 2, 3, 4 carbon, and hydrogen. This is 3, 3, that's 6, 10. 3, 3, that's 6, then 10. So you see that it's the same molecular formula, but they can be structurally arranged and give it a different compound. Okay, so there's other kinds of isomerism apart from structural. I have the geometrical. You can call it C-trans. So geometrical isomerism, Okay, so it's found in compounds like alkanes. Example, alkanes, ENE suffix. If the pronunciation is becoming the same, alkanes, ENE suffix, due to restricted rotation around the double bond. Because of that double bond in alkane. For instance, alkane, ethane is like this. Okay, so this is H, 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 H. So that's it. Because of this restriction of this double bond, you can have geometrical isomerism. So, but what are the importance of isomerism? The importance is that isomers often have different physical and chemical properties. The two compounds that exhibit isomerism are called isomers. This is an isomer, and this is an isomer. Okay, so isomers often have different physical properties and chemical properties. Okay, so we'll go into the next one, functional groups. Okay, so functional groups are specific atoms or group of atoms responsible for the characteristic reaction of organic molecules. So what are the importance? So what I'm just saying now is that functional groups are just like if you have a particular element or compound attached to a hydrocarbon, it gives it that chemical property. It gives it that characteristic that is consistent with that family. So what are the importance of functional groups? Importance of functional groups. Functional groups. Okay, number one. Okay, not importance. Important functional groups. So number one, I have alcohol. Alcohol, not the one that you drink and get intoxicated by, is OH group. If you see OH attached to any hydrocarbon, this makes it an alcohol. General formula for it is ROOH, where R is the hydrocarbon. Example of alcohol is ethanol. You have the chemical compound as CH5OH. So this OH here group makes it an alcohol. Okay. Properties of alcohol is that one is soluble in water. Secondly, it undergoes combustion and oxidation. So soluble in water. Number one property. Number two, it undergoes combustion. That is, it can be burned. Undergoes combustion. And number three, it is can be easily oxidized. Okay, so what are the uses of alcohol? Beverages, yes, beverages. Your beer, this way comes from. Fuels, solvents. These are the uses of this particular functional group. Another functional group we can see is carboxylic acids. Carboxylic acids, let's just be fast on this one. Number two functional group is carboxylic acids. And the radical that is responsible for that is the COOH group. The COOH group. So if you see this one attached to any hydrocarbon, it makes it a carboxylic acid. General formula is R, COOH, where R is any hydrocarbon group. So example, I have methyl alcohol, methyl ethanol, ethanoids, methyl ethanoids. This NO8 makes it this group. Understand? So methyl is CH3, then OH, this is it, methyl ethanoid. Methyl, this is the methyl group, and the ethanoid is because it has two. So methyl ethanoid, two carbon. Okay. So properties is that it has fruity smell. It smells nice. Used as perfumes and food flavorings. Okay. So we'll look at esterification later. All right. So what are the reactions of organic compounds? The reactions. What kind of reactions do we see with organic compounds? Okay. Let me just put it as a heading: reactions of organic compounds. So we are interested in the kind of reaction they go through. The first one here is combustion reaction. Number one, combustion reaction. Mostly they can be burnt easily because of the carbon that is there. So reaction with oxygen to produce carbon dioxide and water. Example, methane reacts with oxygen and gives us carbon dioxide and water. Very good example. Number two, substitution reaction. One of the radicals can be replaced. That is what substitution reaction. It occurs mainly in alkanes. Where hydrogen is replaced by another atom or a group. Example, if I have methane again reacting with chlorine, so this hydrogen is replaced. I'll be having like this. Sorry. Okay, plus acid. Okay, so one of the hydrogen is substituted, you understand, with chlorine, and the remaining chlorine combines with the liberated hydrogen to give us hydrochloric acid. So this occurs in presence of UV light. So I can put UV light on top of this thing like this. Anytime you see anything on top of this arrow, it shows that this is what is present to make this reaction happen. This guy does not participate in the reaction, but it's just like a catalyst or anything that makes it happen. So in presence of UV light, that occurs. This substitution reaction. Then addition reaction. You're wondering why we are using operation terms in mathematics, but don't worry, it's chemistry. Addition reaction. This occurs when alkanes, ENE surface, and alkynes, YN surface compounds react with other compounds or elements. So example is ethane plus bromine will give us this compound. So there is an addition. Then we have what we call esterification. So that esters, production of esters from alcohols. Okay, so it produces ester. So esterification is another kind of reaction for organic compounds. Very interesting. Number 4, esterification. Ester and reification. So reaction between alcohol and acid. So this is basically alcohol reacting with acid to give us what? To give us ester. Swiss-smelling substances. Ester. Okay, but basically this is how it looks like. Example, if I have this compound, this ethanoids, methyl ethanoids plus this alcohol, so it forms this. So this guy, this H is replaced by this guy. This H is replaced by this guy. So I have CH3COO. Instead of having H, I now have CH3 plus water. This one going to form water. So this guy here is called the ester. Okay. So we also have polymerization, another kind of reaction for organic compounds. I want us to go and study this in depth, but if you need personalized consultancy lectures, you can contact me because organic chemistry is a very wide topic, but I'm just giving us this for the sake of the video. So polymerization is another part or another kind of reaction that can occur in organic compound, and this is just the joining of many small molecules, monomers. We call them monomers. They have monomers and polymers, but you join monomers to form large molecule called the polymers. So monomers come together to form polymers. Example of this one, I will just put a general formula: CH2 again. Okay, will form another general polymer. This is it. Okay, this is just beyond the scope of this video, but I will leave it at that. So organic chemistry is actually very wide. I try to do the introduction in this video to stimulate our interest and also to make us to go and research more. And if you need private lectures, you can contact us on Upvision Concepts Academy for detailed tutorial on organic chemistry. It's actually very wide, but this is the video. This is where we're going to stop in this video. There are some questions in the description and the comment section. Please go through the questions and drop your comments as well. Like the video if you are very impressed by what has been given to you, and if you have not subscribed, please subscribe so that more people can see our content. So I hope this video has been informative for you.